Hello everyone and welcome back to the GoFr channel. I am Divya Darshana and today we'll deep dive into version migrations in GoFr. Imagine you're making changes to your database, adding new columns, updating existing fields, or inserting data. Communicating these changes to other developers and ensuring they replicate them locally or in a production can be tedious, error-prone, or difficult to track. Without a proper process, developers might miss out on applying critical changes, leading to inconsistent environments across development, staging, and production. This is where GoFr's migration come to rescue. GoFr provides built-in support for version database migrations across multiple databases like MySQL, Postgres, Redis, ClickHouse, Cassandra, and ArangoDB, enabling developers to automatically alter the state of database in a consistent and predictable way. A migration is simply a set of instructions that helps you add new tables, modify existing tables, insert or update data, or perform any kind of database schema modification. GoFr's migrations follow a versioned approach, meaning each migration is uniquely identified, executed only once, and rolled back if it fails. In this video, we will explore setting up migrations in a GoFr application from scratch. So, let's not waste any more time and let's get coding with GoFr. We will first start with creating a GoFr project from scratch. Here, our project name is HTTP server. We already have the configs directory and a .env file where I have mentioned all the configurations already. In our main.go file, we have initialized an instant app and we have written app.run. I have also already configured the data source for demonstration. In our .env file, we need to make sure to add the SQL configurations to automatically connect to the running SQL instance through our GoFr application. We also need to ensure that we already have GoFr CLI installed. Now, to create a migration, we will use GoFr CLI. That is, we write in the terminal GoFr migrate create and give the name as the name that we want to set up for the migration. In this case, we'll create two migrations having the name create employee table and insert employee data. Once executed, we can then notice a migration folder in our project directory having two migration files and an all.go file that maps the GoFr migration ID to the corresponding migration function. This migration ID is the timestamp of creation to avoid any duplication issues. We will then write two simple migrations. The create employee table, we will first mention the query and then we will write data source.sql.exec and then we pass the query inside it. Similarly, for insert employee data, we will be inserting data for two employees. We'll write one query correct and then write the SQL exec command for it. And then we write the other query a bit wrong deliberately in order to check and observe GoFr's built-in Atomicity support. After writing our migrations, we go back to our main.go file, import the migrations folder that is created, and then write app.migrate passing the migrations.all function. Now when we run the server, we can observe that GoFr automatically executes the migrations. And if we observe the logs, we can see that the first migration runs successfully, creating the employee table. However, the second migration fails and it shows that it has rolled back because GoFr automatically rolls back the entire transaction, ensuring that no partial data is written to the database. We can also check the same by going inside a data source. We can see that a table was created, but there are no records added in it. Because migrations in GoFr for relational databases happen in transactions, so any existing migration queries that were executed in that transactions were automatically rolled back. However, GoFr ensures this atomicity at each specific migrations only for relational databases like MySQL and Postgres. In cases of NoSQL databases like Cassandra, atomicity is not inherently supported at the migration level. In such cases, developers need to write queries effectively to avoid overlapping data. For example, in Cassandra, you can achieve partial atomicity using logged batches while writing migration queries. For more info, refer to the GoFr's official documentation about migrations in Cassandra. Moving on, we'll now correct our query and run the migrations again. And we can see that the other migration is skipped, the one that was previously executed. Now this is because GoFr uses versioning to track which migrations have already been executed. It automatically maintains migration records inside your database itself. For example, for SQL databases, records are stored in a GoFr migration table with the following schema. And for Redis, GoFr maintains migration records in a Redis hash named GoFr migrations, where the key is the migration version and the value contain migration details in JSON format. So GoFr automatically skips previously executed migrations by cross-referencing the records in the GoFr migration table or Redis hash. This ensures that migrations are idempotent, meaning the same migration is never applied twice. To learn more about migrations in GoFr, check out our official documentations on migrations at gopher.dev. Our support is not just restricted to a few data sources, as we are actively working on adding support for migrations in all the other data sources that we support. So if you are interested in contributing, do check out our open source repo at github.com/gopher-dev/gopher, where you can find the open GitHub issues on migrations and get started with it. You can also join our Discord channel for any feedback or design discussions regarding the same. With this, we come to the end of this video. If you found this video helpful, don't forget to like, share and subscribe to the GoFr channel. Thanks for watching and I'll see you in the next one. Until then, happy coding with GoFr.